Hello, we're going to work on the second set of questions in the application section for lesson 2.5 today. So if you can go ahead and turn in your workbook to page 203, here we are. Another good example around scatter plots and linear line of best fit and correlation coefficient. So it says this table shows the average annual cost for tuition, room, and board at all colleges in the United States between the year 2000 and 2014. They want us to draw a scatter plot. And do you think a linear equation will model the data accurately? So because we have years and these numbers are very large, remember we talked about when we get our scaling for a graph, it's important to have our scaling start at 0. And if we use these really large numbers, it would be really kind of hard to read the graph. So when we scale down to smaller numbers, so we use a base year, this time our base year is the year 2000. So that's our 0 year. And then making sure that you're figuring out, these happen to go in order one by one, but sometimes we have data that doesn't. So be very careful if it jumps in years that your X jumps as well appropriately. So I've entered in Desmos, and you should too, 0 through 14. So in Desmos, this is going to be our X1. And then the cost to go to college, and this is an average cost for the year, is going to be Y1. So go ahead and get those entered, and then let's look at the scatter plot. Go to my Desmos to share that with you all. And I've entered mine here in Desmos. Hopefully all my data is correct. And I am going to go ahead and hit the plus button here. And wow, it looks very linear if you ask me. I think it looks very linear. And so I would say yes for number 1. I do think it's a linear model will be good. And then number 2 says, using a graphing calculator or spreadsheet to create a scatter plot and find the line of best fit for the data, then add the line to your scatter plot. So the line of best fit, remember we have, I would say this too in your Desmos, so you've got it. So I'm going to call this the lesson 2.5 college costs. Okay, so I'm going to go down here and I'm going to type, my data is in X1 and Y1, so I'm going to do Y1 and that tilde MX1 plus B. And there's our line of best fit down here at the bottom. And again, I'm going to write down my M and my B off to the side before I write it in the equation. And I'm going to use 1 decimal place, so 795.1. And my B is 10,626.6. Okay, and they ask us a number 7. What is the correlation coefficient? But I like to look at this right away because it tells me. So if you flip over to number 7, let's just write R equals, and the correlation coefficient right there in our little box here is 0.9996. 0.9996. So I'm going to go back to my paper for a moment. So number 7 is asking about the correlation coefficient, and it says, are you surprised based on your answer to question 1? No, we said it looked linear, and this is very good. So it's a very good fit. So we're not surprised. So let's write not surprised, because we guessed it was. So they're asking us way down here on the list. Usually when I get my line of best fit, I talk about the correlation coefficient right away because that helps me decide. But let's go ahead and write our equation. So y equals, and we're going to put our slope 795.1 times x plus my y-intercept 10,626.6. Okay. It says, what is the slope and what does it mean? So my slope is this 795.1, and it's my y units, so cost in dollars over years, right? So we're going to write this out. So it says for every, and remember, you should be using this kind of formal way to write this. So for every 1 year increase, we can expect tuition and costs to increase. I'm using the word increase in both places because they're both positive. To increase by, and whatever my slope is. So this is $795.10. I'm going to go 2 decimal places so that it's my pennies. So don't forget that we're going to look at the units. And so when you describe your slope, you should be describing it in units and both pieces. It's a unit rate. So 4 says, use your equation to predict the total tuition, room, and board cost for the year 2019-2020. So we have to figure out where would that be in our graph. So 2019 minus our base year of 2000 is x will be 19. So in Desmos, let's go to x equals 19 and find that prediction. So I'm going to scroll over a little bit. So 19, so I'm going to click on my line and I'm going to go to 19 and I'm pretty close. Okay, so 19, it's 25,732.99. Okay. So then I'm going to go back to my paper here for just a minute so you can see what we wrote. So it was year 19, and if you look on the Desmos, it comes up with this. So it says, use your equation to predict total tuition, room, and board for the 1990-1991 school year. What X value would correspond to 10 years before 2000? 1990 was my first year at college. Oh my gosh. So 10 years before would be X equals a -10, right? So now we have to go to a -10 in Desmos because it was 10 years before. So let's go. I'm going to grab my Desmos and go back because I have to go back a -10. So back in the average cost there. Oh, I have it. Oh, I keep missing it. There I am. Was $2,675.92. That was way more expensive than that. I can tell you that. To 2,675. And 92 cents. So number 6 says, use your equation to predict the school year in which tuition, room, and board will reach 30,000. So now they're giving us a Y at 30,000. So, okay, so we're still in Desmos. So a Y at 30,000. So in Desmos here, I'm going to, down here below, I'm going to just say Y equals 30,000. And I'm going to see where that line is, and I'm going to hit enter. And notice we can't see it. So I'm going to readjust so I can see it on my screen, because my screen only goes up to 25,000. So I'm going to go back up here, see where my mouse is, where my data is, bottom left. I'm going to hit my magnifying glass, and it's going to readjust. And I'm going to have to scroll over to see this intersection. So I'm going to click on, when I click on the lines, it gives me a gray intersection point, and I can see where that is. And it looks like it's at year 24.4. Year 24.4. So let's go back to our paper and put all this together here. So this was number 5 that we just came up with. And then number 6 is asking us to go backward and say, what year would give me a cost of 30,000? And using Desmos, we came up with this. So the year 2000 plus 24 would be about the year 2024. And I guess it's more than that, but I could be wrong. Now, the one up here, you could have done using the equation if you really wanted to. So up here, you could have said y equals 795.1 times a negative 10 plus your y-intercept of 10,626.6. So you could have done that to get there too. And this one, you could have used algebra with symbols, right? To work backwards to find x. If you wanted to as well. But we're using Desmos as much as possible. We've already talked about 7, the correlation coefficient, very high. And then 8 says, find the residuals for the 2002 and 2008 school years. What do your results mean? So 2002 residual will be actual minus predicted. And then 2008 residual. So 2002, the actual was 12,014. And then I'm going to look up 2008 while I'm at it. 2008 was 17,092. In 2002, so when we go to Desmos to find the predicted, 2002 is x equal to 2, and 2008 is x equal to 8. So let's go find those two predicteds, and we can calculate our residuals. And excuse me, I'm going to scroll back over here. So 2002, I'm going to go to my line, remember, and I'm going to go to 2. So it looks like I'm just at 12,000. The one here where it says, whoops, not that. You're going to use the one on the top left, because the one on the top right, the bottom right, is the green dot, which was our our actual point, right? So this predicted, whoops, I just bumped it. So we want to trying to get as close as I can. Okay, 12,216 and 78 cents. 12,216 and 78. And then we need year 8. So I'm going to go up here, and it looks like, so at 2, it looks like our black line is above the actual. So it looks like we over predicted, and we'll see how we calculate. And then at 8, it looks like our predicted black line is under the actual. So it looks like we under predicted, but let's just see what it says at 8. If I can get it there. There it is. 16,987 and 21 cents. So 16,987.21. So I'm going to go back to my paper so we can calculate this together. So there's our actual and predicted for 2002. And when we calculate the difference here, it looks like, just like we thought, we our predicted our residual is negative, and that's because we over predicted. Our prediction is bigger. And then on the other one, our residual was 104.79, and we under predicted on this one. But overall, our line of best fit is a really good fit. And you can see that by the correlation coefficient. So that rounds out lesson 2.5. Catch us back for 2.6. We're moving on to exponential equations. It's super exciting. We're going to do some modeling. We're going to learn about that multiplication, repeat multiplication that we learned in 2.1 with the compound interest. And now we're going to apply that exponential modeling to real life data. So we'll catch you back then.